So this is probably going to be a pretty popular lesson because advanced factoring can be really tough for children, especially if you feel a little rusty on just regular factoring from last semester. So in this lesson we're going to discuss more advanced factoring techniques. So you're going to see polynomials that are a little larger than what we saw last semester. You're going to see four-term polynomials. You're going to see higher degree of polynomials. And advanced doesn't necessarily mean more difficult. There's going to be a couple patterns that we're going to be using. So never fear, we'll get through it. First, we're going to review some old factoring from last semester. So if we have a general trinomial, remember our first step is to look for any common factors, but 2, 5, and 12 don't have any common factors. So we're just going to factor this like a reverse foiling question. So you start with the first terms. They have to multiply together to give you 2x squared. So we'll be using 2x and 1x. And then we're going to go all the way to the end of the problem and think about numbers that multiply to negative 12. So positive and negative are going to be my signs, but my numbers are 4 and 3, and 6 and 2, and 12 and 1. And I'm going to avoid the 12 and 1 just simply because they're very far apart. But, let's try 4 and 3. So I know not to put the 4 in this parenthesis because 2 and 4 would have had a common factor and there wasn't one. So if I'm going to put the 4 anywhere, I'm going to put it there with a 3 here. Now if we make this a negative 4, that'll give me a negative 8. Plus 3 in the middle arch. And remember, your arches have to add up to the middle number. Which they do. Sorry, so I had a visitor for a minute. Alright, come back. We have negative 8x. And then a plus 3x. Which do add to negative 5 in the middle. So that's the correct factorization for that trinomial. So we have other trinomials that maybe are a little less intensive. That one was pretty tough because of the coefficient of 2. This one is a perfect square trinomial. If you notice that the first term and the last terms are perfect squares, then that kind of leads me to believe I should be using the square root factors for both of those. So 1x squared would be x and x, and then 25 would be 5 and 5, and then positives for everybody, and the arches would add up to 10 in the middle. You could also rewrite this, since it is x plus 5 times another x plus 5, you could rewrite it as x plus 5 quantity squared. That's the same pattern that we saw in completing the square last semester. Right, now for my favorite pattern, if we have the difference of two perfect squares, the way we're going to factor that is with I think we called it a good twin, evil twin, or the conjugate pattern. You take the perfect square, the square root pattern here, so 2x and 2x, the twin factors, and then 9 would be a 3 and 3. And then if you make one sign a plus and one sign a minus, then we have that conjugate action where the middle of the foiling will cancel out to nothing, and that's why we don't see anything in the middle of our original problem. And then the kind of factoring that everyone forgets about is taking out a common factor. So common factors can be numbers, they can be variables, so 6 and 15 can both be divided by a 3, and then x squared and x both have an x. So if I remove or undistribute that common factor of 3x from this, I still have a 2x plus 5. We did a lot of taking out common factors last semester on various types of problems, so you're going to see that again this semester. Alright, so this is a different version of something that we've already seen before. This is another version of the factoring flowchart, so if you still have your factoring flowchart, you're welcome to use it. You're going to actually get a new one where there's extra patterns that are added, and these guys right here are the extra patterns. We have the sum of two cubes pattern, which would start off looking like this, and then it's going to factor into this pattern right here. So this is going to be what your answer looks like, and this is what the original problem will start off as. And there's also a difference of two cubes. So again, the pattern starts off like this, and then you're going to factor it to look like this. So this is what your answer would look like. So off to the side here, they have some examples of this. The sum of x to the third plus 8 is going to factor into this, and we'll talk about how we come up with those numbers in a minute. And then this is a difference of two cubes pattern. So if I gave you that problem, you're going to be able to factor it out like this. So I know it looks really complicated, but a lot of kids end up liking that question because it's just a nice pattern. So a little bit of a downside. At some point you should try to memorize it. Alright, so first thing I do, no matter what, is I look for a common factor. X to the third plus 27, they don't have any common factors. So it is 2 terms long, which means that it's going to be one of my special patterns. It's either the difference of squares, or it's the sum or difference of cubes. So first of all, it's got a plus sign in the middle, so it tells me it's the sum. And the other thing I notice is x to the third and 27, those are cubic numbers. So what I'm going to have you do is recognize that this is the sum of two cubes, and then write down the formula that we're going to be plugging into in a moment. So from the other screen, the formula for sum of two cubes was a plus b, and then a squared minus ab plus b squared. So as long as I can figure out who is a and who is b, this is going to be a really easy question. Well, this, remember, is a cubed according to the pattern. So if off to the side, I just want to write down who a is the cube root of this, which would just be x. And then this is supposed to be b cubed. So if I got to think backwards, who is just b, that would be the cube root of 27, which is 3. So you can use your chart, you can use your calculator, or best of all, you can just use your brain. The cube root of 27 is 3. 3 times 3 times 3 is 27. So we're going to take this a and this b and plug it into this formula. Here we go. So a, which is x, the signs are already built into the formula. That's why I like this a lot. A plus b is x plus 3. And then a squared would be x squared minus a times b, which would be x times 3, better known as 3x. Order doesn't matter when you multiply. Plus b squared, which would be 3 squared, also known as 9. And the best part about the cubic patterns is once you use the cubic pattern, you're done. There's never going to be any further factorization. We're going to see some problems today where like you think you're done and then it looks like you can factor again. So this is the final answer. Alright, this next one is a little more exciting. It will have a common factor that we're going to take out. 16 and 250. Oh goodness, let's see. I know they're both divisible by 2 because they're even. And I think that's all they're divisible by as far as coefficients. So we're going to take out a common 2, and I also see a u squared. So the first thing we're going to do is undistribute that 2u squared. And I'm definitely going to have to move my face out of the way. There we go. So taking out a 2u squared to the front of the problem is my first step of factoring. And that's going to leave me with, let's see, 8u to the third minus 125. It'd be awesome if we were done, but we're not. What I just wrote down in red is 2 terms long, and it is the difference of 2 cubes pattern. So what we're going to have to do next is we're going to leave the 2u squared in front, but we're going to use the difference pattern, which I'm going to write down in green down here just so I don't get confused. The pattern is a minus b, a squared plus ab plus b squared. As long as I can figure out who a and b are, I can just place them into that green formula, and then I am done. So this is the tricky part, is figuring out who a and b are. So this is a to the third power. So if I think about cube rooting that term, or undoing the third power, that would leave me with 2u. And then this is b to the third power, so if I think about undoing the third power, or cube rooting it, the cube root of 125 is 5. So this is what I'm going to place into these green guys. Alright, ready? 2u squared still there, but the pattern and the signs are already built in, so don't worry about any signs. It's a minus b, so 2u minus 5. This part gets a little tricky. If I square the a term, which remember is 2u, think about squaring that, guys. We're going to be squaring a 2 and a u. So that is a 4u squared plus a times b would be 2u times 5, which is 10u, plus b squared. 5 squared is 25. Ooh. So the good news is, once you use the cubic pattern, you're done. I don't care what kind of problem you're doing. As far as factoring, that's the last step. The hard part is knowing how to place everything into the formula. So that was a really tricky question. Don't panic. If you're like, oh, I can't do that. That was a really tough one. Alright, number 3. 25x to the fourth minus 36. There are no common factors. We're going to skip down to looking at how many terms. It is 2 terms long. So do we have the difference of squares or the difference of cubes? Well, 25 and 36, those are square root numbers. So we have this pattern, the difference of squares pattern, which is the one that we used all last semester, the good twin, the evil twin pattern. So if I look at my twin factors for 25x to the fourth, that would be 5x squared and another 5x squared. And then my twin factors for 36 would be, we're going to use a plus 6 and then a minus 6. And we still need the conjugate sign, so that way there's no middle term in the middle of the foiling there. And that's actually done. sometimes, and you got to be careful, as much as we love that pattern, sometimes there's another level of factoring. Like for instance, if this factor right here was, I'm making this up, 9x to the second minus 4, that would be another factoring question that we'd have to continue with, and I will kind of trick you like that, so be careful. All right, number 4. No common factor, so move on to the second step where I see that it is 2 terms, and I have to decide if it's the difference of perfect squares or the difference of perfect cubes. So x to the third power is kind of a dead giveaway. This is the cubic pattern. So we're going to be factoring into, I'm just copying the pattern, a minus b, a squared plus ab plus b squared. So as long as you can tell me who a and b are, we're going to be in business. So if this is a to the third power, that means a is just plain old x. And if this is b to the third power, remember that's the pattern, that means b is the cube root of 8, which is 2. Remember, you don't have to worry about signs here. Alright, let's plug them into the formula. So the formula starts a minus b, so x minus 2. And then a squared, so x squared, plus a times b, which is 2x, plus b squared, which is 4. And then remember the best part about this pattern? You're done. Once you use it, you're done. And that only goes for the cubic pattern. That's the only 2 patterns where that's true. All right, 27 and 1 do not have any common factors, so we must have a special pattern. It is the difference of, and these are cubic numbers. So this is the a to the third minus b to the third pattern again, which remember we're going to factor into. I'll write the pattern out just to get used to it. And sometimes just writing the pattern this many times helps you memorize it. A minus b, a squared plus ab plus b squared. Alright, so if you can tell me who a and b are, we're going to be in business. A is the cube root of this, so 3x. And b, oops, is the cube root of 1, which is very boring, it's just a 1. So, into our formula here. A minus b would be 3x minus 1. And then be careful on this first term, a squared. If you're going to square this entire term, hello, what's an x? You're squaring the 3 and the x, so that's a 9x squared. And then plus a times b would be 3x times 1, which is just 3x. What color to write that in? I'll just write it in black, I guess. And then plus b squared, 1 squared is 1. And again, favorite part about this pattern, once you use it, you're done. Alright, now brings us to a 4-term polynomial. We have not seen this at all. You may have seen a little bit of this in Algebra 1, but in this full chart it says if you have 4 terms, you're going to do what's called factor by grouping. This might be your new favorite kind of factoring, by the way. A lot of kids really enjoy this. You're going to realize that there's no common factor in the whole problem, so that's a bummer. But if you were to group this problem into 2 halves, color-coded as such, and look at each of these problems as their own little mini factoring problems. So x to the third minus 2x squared. If I was just going to factor that expression, I notice that there's a common x squared that I could take out. And if you take out the x squared, you still have an x and a minus 2. All right, we're going to do the same thing here with this blue pattern, but we're going to take out a common factor. And a 5 is usually what kids see. However, the fact that the first term is negative kind of makes me think, what if I took out a negative 5? Because we really don't like that first term to be negative. So if you notice the first term is negative, go ahead and take out the negative with the number. And if I took out a negative 5 from here, now I have a positive x. And if I took out a negative 5 from here, I have a negative 2. And you should notice that if you look at the entire problem, from here to here, this is one term, and this is another term. But within those 2 terms, there is also a common term of x minus 2. So what you're going to do is you're going to take this x minus 2 term, and this x minus 2 term, and factor it all the way out of the problem, way out to the front. And now look at what's left. If you took out those x minus 2's, so this is out in front now, and this is out in front now, you have x squared minus 5. And I got a little weird and I put brackets in green around this, but if you would like to switch those out for parentheses, you're more than welcome to. I was just trying to illustrate to you like where we went with the terms. This is the factorization, x minus 2 times x squared minus 5. Now this is another one of those cases where because it wasn't the cubic pattern, you do have to be careful. Sometimes one of these factors will factor again. Like for instance, if this was x squared minus 9, I'd have to factor again because that factors. Turns out this problem is done. That is the complete factorization. We'll practice that a little more right now, don't worry. Alright, so my first two terms here and my last two terms, we're going to be factoring them in groups. So this first group, I see a common, not much, just an x squared. And when I take out an x squared, I still have a 2x and a plus 3. And then taking out, there's not much to take out here other than the fact that there's a negative in front and I don't like it. So what if we took out a negative 1? You have to take something out of groups. So if it's just a 1, that's okay. If it's just a negative 1, that's fine too. So this becomes a 2x plus 3. So now when you look at the entire problem, I notice that this term and this term, they both have a common factor of 2x minus 3, or plus 3, 2x plus 3. So if you take that 2x plus 3 out in front of the entire problem, and you can use those green brackets if you prefer, but look what happens when you remove the 2x plus 3 and this 2x plus 3 and you take them out. Now you have x squared minus 1. Now in the last question, we were done after this step, and we just boxed it in and we moved on. However, look at this, x squared minus 1. That's the difference of two squares. You can factor this with those twin factors, x plus 1 times x minus 1. And then the 2x plus 3 is still out in front. Ooh, that was fun. And that's what we mean by advanced factoring techniques. They're much larger problems as far as how many terms there are. It might take you more steps to get the final answer. Just stick with it. All right, let's try another factor by grouping. Let's use my colors again. 2x squared plus 5x. We're going to take something out of there. And then 10x plus 25. We're going to take something out of there. So only thing I can remove from this blue box is an x. And that leaves me with 2x plus 5. And then from this red box, I can take out a 5. But it is a positive 5, and I need a sign with my factor. So let's leave it as plus 5. And what do you know? I am left with a common 2x plus 5. You'll notice in these factor by grouping questions, if these parentheses, the leftover parts, if they don't match, you didn't do it right, frankly. Or it's possible you can't factor by grouping, but I wouldn't be that tricky and do that to you. So 2x plus 5 is the common term that I'm going to take out in front of the problem. And then what's left, once you remove those 2x plus 5s, you have an x plus 5. Now, neither one of those parenthesis sets factor further, because they're both linear, they're not even quadratic, so we're done. Alright, we've been on this kick of factor by grouping because they each had 4 terms, but not everything is factor by grouping, guys, so don't get too excited. Number 9, I have a trinomial. I still have to go back to my first step of looking for common factors, and you know what? We do have a common factor here. We could take out an x. So if I took out an x from this original trinomial, I still have x squared plus 3x minus 10. And wouldn't it be nice if we were done? We're not done, because what I just wrote down in black is further factorable. So keep the x in front, and then now you're going to factor for me the x squared plus 3x minus 10. And let's see, that should be a pretty easy one for us, right? X and x is x squared. Multiplies to negative 10, adds up to 3. How about a plus 5 and a minus 2? So your complete factorization is x times x plus 5 times x minus 2. Those are the kind of questions we saw a lot of last semester where I could tell if you copied the answer key because you didn't have multiple lines of work, and some kids just wrote down the answers, and then I was like, hey, clearly you didn't do those. So we're on to you guys. Let's not be that kid. All right, I'm going to kind of look through my examples coming up here, and there's still a ton of practice problems coming up. I think as far as the lesson goes, this is enough examples of the types of factoring that you're going to see and how to use the flowchart. We're going to be practicing this to death. So I'm going to end the lesson here. If there's one particular type of factoring that you know you need to see again, go back and look at that problem again, and then go further into your notes and practice them. But trust me when I tell you we're going to be hitting factoring pretty hard. Factoring is super crucial to an upcoming lesson and an upcoming unit. So don't worry, I won't let you leave me without knowing how to factor like a ninja. Good luck.